All right, welcome back. I have another question in chemistry. So we're given this balanced chemical reaction. So it's already balanced, which is nice. And this is talking about the production of this right here. This is nitric acid. Remember, nitrate, so itis, nitrate becomes nitric acid. And then this is not an acid because there's no hydrogen. This is just nitrogen monoxide. This is nitrogen dioxide. And hopefully you guys know this one. This is water. Okay, so this is already balanced. And the question says how many grams of nitrogen dioxide must react with water to produce 5 times 10 to the 22nd molecules of nitrogen monoxide. Okay? So, let's see if we can get all this in one shot here. Okay, so I always say start with basically anything in the problem that you know. So you know you have 5 times 10 to the 22nd molecules of nitrogen monoxide. And our goal is to get grams of nitrogen dioxide. So we're going to need obviously our periodic table for this, but let's start with this. So start with what you know always. So 5 times 10 to the 22nd molecule. So don't write MOL because then you're going to get it confused with moles. So nitrogen monoxide, NO. So we have this, and we're trying to get to grams of nitrogen dioxide. All we need to do is our stoichiometry, our unit conversion until we get to grams of nitrogen dioxide. So we have molecules of NO. Well, what do we know about molecules? Well, we know that there's Avogadro's number, right? So there's 6.02 times 10 to the 23rd molecules of NO in 1 mole of NO. That's just Avogadro's number. You'll always be able to use this to go from molecules to moles. There's this many molecules in 1 mole. So right now we're in moles of NO. And we were trying to get to grams of nitrogen dioxide. Well, here's nitrogen monoxide, and here's nitrogen dioxide. So we need to do our mole to mole ratio. Well, there's for every 1, so it's implied, you don't actually have to put a 1 there, but there's for every 1 mole of NO, there's 3 moles of NO2. Okay, so now we're in moles of nitrogen dioxide, but we want to get grams. So how do we go from moles of something to grams of it? We need to use our periodic table. So let's just do a little part down here. So the molar mass of nitrogen dioxide. Well, that's nitrogen is 14.01 plus 2 times oxygen, which is 16. All right, so do our little calculator here. So we've got 14.01 plus 2 times 16. Got 46.01. So that's our molar mass, 46.01 grams per mole. That's straight from the periodic table. Well, so that means we're in moles of NO2 right now. So for every 1 mole of NO2, it's 46.01 grams of NO2. And there we went, grams of nitrogen dioxide. That's what we're in, grams of nitrogen dioxide. So we're going to do the top. So this is how I like to solve these. I wouldn't even give any other option. You have to do it this way. So all the top, get that answer, multiply this times this times this times this, get that answer, and then we're going to divide it by this times this times this. So 5 times 10 to the 22nd times 3 times 46.01, you get 6.9 times 10 to the 24th all over, well, 6.02 times 1 is just 6.02 times 10 to the 23rd. So I'm going to divide the top by 6.02 times 10 to the 23rd. So you get 11 point, our answer is 11 point. So here we go. We have 3 significant figures we're allowed. So are we allowed to do, the answer is 11.46. But that would be 4 sig figs, so you have to round this. So it'd be 11.5, and the answer was in grams of nitrogen dioxide. All right, so a little recap. We have a balanced reaction. That's the most important part. If it's not balanced, you're not going to have your mole to mole ratio, but it's already balanced. It says, well, it doesn't, don't even think too much about why you start with this. Just start with the number they give you. Molecules of nitrogen dioxide. And then how many grams of nitrogen dioxide? So you start with molecules of nitrogen monoxide. Change molecules to moles by the Avogadro's number. Moles of NO to moles of NO2 is a mole to mole ratio. And then once we're in moles of NO2, we want grams. So you just, this right here is the molar mass that we used the periodic table for. And then you just solve. So 11.5 grams of NO2 will be created if, well, actually, it's backwards. It's kind of weird. So how many grams must react? This is a product, and this is how much of the reactant we needed. Okay, so hope that helps. And watch this video as many times as you need to understand, but they all work in a similar way.